So in this video, we're on page 10, and we're going to be taking a look at some more two-step equations and continuing to get used to some unfamiliar formatting. Now, before we do anything with this page, I'm actually going to switch over here and talk to you guys about something called standard form. Now, standard form is up here. It's the thing I'm highlighting that says that you're going to have A times some number plus B equals C. So this is our coefficient times our constant, or sorry, excuse me, our coefficient times the variable plus the constant equals a total. So what that means is if you see an equation like 3x plus 4 equals 10, it is in standard form. Now there's a couple of things we can do here. I could switch the order of these two terms and have it 4 plus 3x, and that would still be the exact same equation. Another thing I could do is I could simply switch the side that the expression is on versus the total. And those are some examples right here. I could have the 3x plus 4 equals 10, or 4 plus 3x equals 10. All of these equations are the exact same problem, and they all have a constant of 4, which we'd subtract first, and then we'd divide by a 3. Okay? So in all of these occasions, we're going to subtract the constant and then divide by 3. Now here's another problem. If you saw 4x minus 2 equals 18, that is in standard form. You have the coefficient with the variable, then you have your constant, and then you have equals the total. But if we switched up these two terms right here, if we just simply switch these two boxes, that means the negative 2 would come first, and then we'd have a plus sign with our 4x. So if you saw the equation negative 2 plus 4x, it's the exact same thing as saying a 4x minus 2. So all I wanted to do was point out here that you can switch the order of the terms, and that is what might make it look like you don't know what to do. So if you have any unfamiliar formatting, it might be because it's not in standard form, but we're still going to be undoing the order of operations, and we're still looking for the constant first. And in these problems right here, because we have fraction bars, we're going to be multiplying both sides by the denominator in our second step. So this blue highlighted problem over here, it's currently not in standard form. If you saw the x over 2 plus 5 equaled 11, then it'd be in standard form. And let's take a look at what you'd do here. If you saw x plus 2 equal, or x over 5 plus 2 equals 8, you would subtract the 2 on both sides, and you would cancel out this constant right here, and 8 minus 2 would be your 6. Then you have x divided by 5, so you'd multiply both sides by 5, and you'd cancel it out, and you'd get your final answer, x equals 30. So now, the problem that you're looking at, the only thing that's different is we just switched where you see the equals 8. So that doesn't change a thing. You still drop your line and say, okay, what's my constant? Here it's a positive 5, so I'm subtracting 5 from 5, write it right underneath it. And then you subtract your 5 on this side. It would cancel out over here, and you're left with x over 2 on this side. Over here, we have 11 minus the 5 is the 6. And so now we're going to simply multiply both sides by the denominator of 2. So over here we see 2 times 6 is 12. And then that would equal, that cancels out our x right here. And to check, you can just do 12 divided by 2, which is 6, and 6 plus 5 is 11. All right, now we got to be really careful here for number 2. We're going to drop our line, and we're going to focus over here and ask ourselves, what is the constant? The constant is this 15, and since it's positive, we're going to subtract 15 on both sides. So it's going to cancel out over here. 15 minus 15 is gone, and we got to be really careful, y'all. There's a negative here, so we have a negative with this k over 3. Now on this side, we have 3 minus 15 is a negative 12. Now one thing that I want to point out here is that the negative, it doesn't matter if it goes with the numerator or the denominator. And so that we don't forget about it, I'm going to push that we put the negative down here with the denominator. That is still a negative k over 3. Okay, that's still a negative overall. So now what we're going to do is we're going to multiply both sides by that negative so that we don't forget about it. And this negative divided by negative would cancel out, and we have k equals positive 36. Okay? Now real quick, what I'm going to do is I'm going to just erase part of this work to talk about what happens if you don't put the negative in the denominator. Let's see what happens, okay? So if we don't put the negative in the denominator, if we either leave it out front or with the numerator and just have a 3 down here, then you're multiplying both sides by just the 3, okay? And be careful on this side. What that now means is that over here we'd have a negative 36, but we still have the negative with this k, and so technically we have a negative 1k. And at that point, you'd need to take it a step further and divide both sides by that negative 1. So now the negative divided by negative cancels out, and k here would be the positive 36. So it doesn't matter how you think of it, we're still going to get a positive 36 for this one, but to avoid this second additional step down here, I think it's easier to just go ahead and put the negative in the denominator, and you're dealing with it already in that step. So here's another one just like it. Let's practice. You're going to drop your line and say, okay, so what's your constant? My constant is 7, so I'm subtracting 7 on both sides. That cancels it out over here, and 11 minus the 7 would be a 4 on this side. So the y, I'm going to put the negative down with the 3. There's the negative. I'm going to highlight it in red so it stands out. That negative is simply down here now. And now we're going to multiply both sides by this negative 3 for it to cancel out. Over here, the negative 3 divided by negative 3 cancels out, and we're left with just our y. And on this side, we're going to get a negative 12. Now when we check, we're going to be careful here because we have 7 minus, and now we're going to put in a negative 12 in the numerator, and then over 3. So PEMDAS says right here, we're going to get a negative 4. But we have a 7 minus out in front, and when you minus the negative, that turns into addition. And 7 plus 4 is the 11 right there that we were expecting. Okay? All right, so now we're going to try some more problems here. It's okay if you want to pause the video at any point, y'all, and just check the answers by skipping ahead. That's totally fine, but if you want to just let the video play for this next one, the constant's a negative 4, so I'm going to add 4 to both sides. All right, this cancels out my constant, and I'm left with a g over negative 5. And notice this already has the negative in the denominator. And over here, negative 6 plus 4 would be our negative 2. So now since our denominator is a negative 5, we're going to multiply by negative 5 and multiply by negative 5. So that'll cancel out right here. You have g all by itself, and we're going to get a positive 10. Now let's check. So you've got 10 over negative 5. That's negative 2. Now we're going to take away 4 from that answer. So that's the negative 6 that we should get. All right, just a couple more here. For number 5, when we drop our line, we have a negative 8 as my constant. So we're going to add 8, and we're going to add 8. All right, that cancels out, and we're left with r over 4. And since it's a positive, we don't got to worry about it. And we have negative 3 plus 8. So negative 3 plus 8 would be positive 5. Now, since our denominator is a 4, we're going to multiply by 4. And don't forget that that's technically over 1, and that's the 4r over 4, where that just cancels out, and you're left with just r over 1, which is r. Now, on this side, we're going to multiply by 4 as well, and 5 times 4 would be 20. And last but not least here, we have z over negative 2 minus 16 equals 6. So we're going to drop our line and we're going to add 16. Notice I'm writing it right below the minus 16 to see that that cancels out. Here's my plus 16 over here. And on this side, I'm going to get, that's going to be 22. All right. Now we have the z over negative 2 left over. So for our final step, we're going to multiply both sides by the denominator. And multiply here by the denominator of negative 2. So we get a negative 44 on this side. And over here, this cancels out, and we're left with z. And to check, we're just going to take the negative 44 in the numerator for z, divide it by a negative 2, and we're going to take away 16. So that right there is a positive 22. And when I subtract 16 from that, we get 6. So we know we did the right thing. And that concludes the video on how to solve these equations, getting used to some unfamiliar formatting if it's not in standard form. Thank you.